Students, in this video I will be going through 3 examples of dividing rational expressions. So what I'm going to do, okay, is to demonstrate to you when we're dividing rational expressions, it's really no different from dividing, let's say, fractions, okay, with actual numbers. So say, for instance, I give you the following fraction, right, 6/5 divided by 12/25. This is the same thing as 6/5 divided by, with a long fraction bar, okay, 12/25. And whenever we're dividing fractions, okay, this is equivalent to multiplying by the reciprocal of the denominator. So this is the same thing as 6/5 times 25/12. And again, what we want to do is we want to, instead of multiplying across, we want to see whether or not the denominator and numerator, whether they share any common factors, and indeed they do. 5 and 25, right, they cancel. 25 becomes a 5. And 6 and 12, they cancel, right, and this becomes a 2. Alright, so this becomes just simply 5/2. So there would have been a lot more like computational effort on my part, okay, if I were to just multiply across. Again, that was a practical skill that I demonstrated in the last video, as well as you guys had practiced in the last exercise. So we are going to go through again, just practicing what I just demonstrated now with something a little more abstract, which is this algebraic expression here. So let's take a look at what we can do with this. Alright, so this is treated no differently, okay? So the first expression here that's in the parentheses, understand that this is also a rational expression. This is divided by 1, okay? And that this expression, okay, this quotient, is the same, it's equivalent to 4p squared plus 36p divided by 8p squared minus 4p over 8p cubed minus 4p squared. When we're dividing fractions, we got to multiply by the reciprocal. So this is equivalent to 4p squared plus 36p. Actually, I'll rewrite this to over 1 just to prove a point, or demonstrate a point rather. Okay, so this is over 1. So this is equivalent to 4p squared plus 36p over 1 times 8p cubed minus 4p squared divided by 8p squared minus 4p. So again, rather than just multiplying across and then having to FOIL and have to do all that work, well, let's see if there are any common factors between the numerator and denominator. So looking at this, okay, the numerator of the first fraction, there's a common factor of 4p. And if I factor that out, I'll end up with p plus 9 inside the parentheses. The second fraction that I'll end up with is, looking at the common factors in the numerator, I see that there's 4p squared that I can factor out, and I'm left with 2p minus 1. And the denominator, I can factor out a 4p, and I'm left with 2p minus 1. So looking at this right now, the 4p and 4p, they cancel. The 2p minus 1 and 2p minus 1, they cancel. My final answer, the quotient, okay, to the quotient of this to this original problem here becomes 4p squared times p plus 9. Remember, multiplication is associative, so it doesn't matter which way you write it. Alright, so this is my answer. However, with this equation that we have here, p doesn't work for every single value here. We need to actually state what the domain is, okay, between for this solution here, for this equation. So, looking at this, okay, there's nothing that p couldn't be. Okay, p could be anything in that fraction there, so I'm good. We need to decide on what's happening here. Okay, so remember the denominator, okay, cannot go to 0. But you also have to understand that this fraction, when I say this fraction, I mean this overall thing, this overall fraction is being divided into 4p squared plus 36p, right? That fraction is in the denominator. It's here. So technically speaking, okay, the whole thing, 8p squared minus 4p, right, cannot equal to 0. Nor can 8p cubed minus 4p squared, nor can that equal to 0. If any part of the denominator ever go to 0, then the entire problem will be undefined. All right? So with that said, we got to find out what p cannot equal to here. So here I can see, just going to rewrite this. I can see that 4p is a common factor, right? So I have 2p minus 1, and here 4p squared is a common factor, and again I have 2p minus 1. Looking at this, p cannot equal to 0 or 1/2. And it just so happens between the numerator and denominator we have the same things that it cannot equal to, and that's okay. Let's take a look at another example. Pause the video to see if you can simplify this and state what the excluded values are. Hopefully you guys had some time to think about this. Let's take a look at this now. So if I have 15m squared minus 55m plus 40, I immediately see that I can factor certain things out. This is really the same thing as 5 times 3m squared minus 11m plus 8, all divided by 5 times m minus 1. And I am going to flip the denominator, flip the second fraction, right, to have m squared minus 6m plus 8 over 40 minus 7m minus 3m squared. Now, this right here, I don't like the way that this is written, just because I'm not used to factoring things well and written like that. So what I'm going to do is I'm going to rearrange this as 3m squared, right? And I'm going to factor out a negative. 3m squared plus 7m minus 40. I don't like the leading coefficient being negative, which is why I factored out the -1. Alright, so now that I have this, okay, I'm going to try and factor this. So what I'll end up with is 5, and I'll have a 3m here and an m there because 3 is prime. That's the only way I can get this. I need 11 to be in the middle. I need the last number to be 8. So that means, well, what does that mean? I need this to be 4 and 3. No. I need this to be 8 and 1. Because 1 times 3 is 3. 8 times 1 is 8. 8 plus 3 is 11. So I need this to be minus and minus. All divided by 5 times m minus 1. And then times, the numerator factors out to be m minus 4, m minus 2. The denominator factors out to be 3m, or negative, and then 3m and m. I need 40, negative 40 to be at the end there. So 8 and 5 makes 40, but I need 7 to be in the middle. So if If I have 5 here, that's 15. 15 minus 8 is, in fact, 7. So I have 8 there. All right, so that means this is going to be plus, and this is going to be minus. All right, and then from there, okay, I want to see if I can simplify anything. I see that I have m minus 1. They cancel. 3m minus 8 cancels. And 5 cancels. Whoops. And nothing else cancels. So my final answer is negative m minus 4, m minus 2, all divided by m plus 5. This is my final answer. This is my final answer. However, I also need to state the values of m that this cannot equal to, right? So now check this out, right? This is a denominator of the first fraction. If the denominator of the first fraction were to equal to 0, then none of this would work. So in other words, 5m minus 5 cannot equal to 0. And then looking at the second fraction, if any part of this were to equal to 0, if either the numerator or denominator were to equal to 0, then I would be dividing by 0, and that would not be cool, right? So then looking at this, none of these can be 0, and none of these can be 0. So in other words, m minus 4 cannot be 0. m minus 2 cannot be 0. 3m minus 8 cannot be 0. And m plus 5 cannot be 0. So all those things, if all those things cannot be 0, then that means m cannot be, right? The first one here is m cannot be 1. Then the next one would be m cannot be 4. Then the next one, m cannot be 2. Then the next one, m cannot be 8/3. And the last one, m cannot equal to negative 5. Some m cannot equal to any of these things. If it does, then either side of the equation that we have here will not work, right? It will be undefined. But it will work for any other values of m. Alright, let's take a look at another example. Pause the video to see if you can figure this out. Hopefully you guys had some time to think about this. So I have 21n squared minus 21n minus 42. I immediately see that I have a common factor of 7. So I factor out a 7, I end up with 3n squared minus 3n minus 6. I take that back. That's not the GCF. The GCF is actually 21. 21n squared minus n minus 2. And then the denominator is 3, n minus 2, and multiplied by 3 times n minus 8 over, there's a common factor of 7, so 7 times n squared plus 4n plus 3. I am going to try and factor this now even further. I'm going to get rid of this. And I'm going to get rid of this because I will factor them. So that factors into n minus 2, n plus 1. And the other over here factors into n plus 3, n plus 1. So if I were to multiply this out, okay, notice that n minus 2 cancels, n plus 1 cancels, the 3 and 3 cancels. I'm left with 2 times n minus 8 over 7 times n plus 3. And then checking out what n cannot equal to, 3n minus 6 cannot equal to 0. right? That's the denominator of this. And then this whole thing cannot equal to 0, because if it does, then I'm dividing by 0, and that wouldn't be cool. So that means n minus 8 cannot equal to 0. That also means n plus 3 cannot equal to 0. That means n plus 1 cannot equal to 0. So knowing knowing that all these things cannot equal to 0, I can see that n cannot equal to 2, 8, -3, and -1. Okay? So that's the final answer there. Because again, this whole thing, let me just move this. Remember, keep in mind that that's what this is equivalent to. Okay? All right.